And so the user has a correctness specification for this program that we think about in the mathematical integers. And if you give a specification that's in modular arithmetic, it may be too weak a specification because it hasn't proved for the user that things haven't wrapped around. So by using the mathematical integers in our specification, that forces us to remember where to put these preconditions. If I didn't put that precondition there, then either I couldn't prove the body of the function or I couldn't prove the caller of the function in some appropriate way, and things would break. So it's usually pretty straightforward. You pass around the mathematical integers and you give quite standard specifications that, yes, it's actually representable. And that way your specification will be more about, from the user's point of view, of what numbers the user thought were being calculated here. Other questions? Yes?
So the specs of malloc and free you showed at the beginning, do they come from CompCert or are they part of VSD?
The specs of malloc and free that I showed are a little bit oversimplified. They'll do for here. CompCert has some sort of magic definition of malloc and free built in that I don't really believe. Malloc and free are part of the C standard library. They're implemented in C. They manage a pool of memory with some data structure to keep track of an array of free lists indexed by size and so on. And so these really should be perfectly ordinary C functions with perfectly ordinary C function specifications. And this malloc token should be nothing more than the abstract data type of its data structures for keeping track of things. And you'll find that if you do that, you need actually one more separating conjunct here in the precondition and here in the postcondition, which is the abstraction of the data structure that the malloc free library uses to keep track of the free list. And David Naumann of Stevens Institute of Technology has verified such a malloc free library in verifiable C, and pretty soon I expect we'll put its actual fun specs into the standard library and into this example. Other questions? Yes?
You mentioned the solution to sort of infinite loops, but what about infinite mutual recursion between methods?
Right. So the only problem with infinite recursion is that you might run out of stack. And right, otherwise it's no worse than an infinite loop. And right now CompCert's operational semantics doesn't have a very strong way to reason about stack overflow. It assumes the stack is infinite. And that's not actually a great assumption. So a better way to do it would be to prove resource bounds about stack height in the source program, carry those proofs through the compiler correctness proof, and so on. And there's work that's been done in that direction at Yale in Zhang Xiao's group. And one of these days we should put that into verifiable C so that there's a kind of stack height resource you pass around between one function call and another. Other questions? Yes?
Related to that, do you handle other sorts of out-of-memory situations or prove that they don't happen?
Well, we prove that they don't happen. So what are the other sorts of out-of-memory that you could have? There's mallocing something when you can't get any more. So on the one hand, here it says malloc might return a null pointer. And there's stack overflow. And what else is there? Now, for malloc and free, you might like to prove that if I only am going to malloc this much, and I start on a computer with that much memory, I won't ever get this null pointer, and therefore I could use a simpler postcondition for malloc. And so that's a sort of resource-bound property of the specification of a malloc-free library, and I think David Naumann has the intention of putting that kind of stronger specification into his malloc-free system so that you can have this stronger postcondition that you really want for malloc. Yes?
That's not actually true because if I have memory fragmentation and then you run out of
But the memory resource, the abstract memory resource that you pass to the malloc-free system is not a single number. It has to be a vector indexed by sizes. Because as Knuth, Volume 1 tells us, you can never completely recover from fragmentation. Unless, of course, we use systems all the time that recover from fragmentation. They're called ML and Java that have garbage collecting memory that moves objects and compacts them. It's only languages like C that are too timid to move objects around. Yes, any more questions?
If you want to specify circular data structures, like circular graphs, like graphs.
Yes, you can do circular data structures just the same way you can do overlapping data structures. So, again, I'll talk about that maybe in a later lecture. But you have to deal with sharing. Once you've dealt with sharing for overlap, then sharing for circularity is not much harder. Yes?
What motivated you to choose using actual C as opposed to creating some language?
What motivated me to choose actual C programming instead of some toy language like everybody else does? Hubris and overconfidence.
Bravo for trying.
Yes, well, okay. So now I just about am out of time, and I think I'll have to defer showing how to do a function call to the next lecture.